Okay, so as in the last video, we have read about rules of electronic configuration, how we're gonna write electronic configuration of any element which is present in the periodic table, right? We follow basically three rules because n plus L rule and alpha principle both are same. So we consider these both rules as a rule only. Okay, so there are three rules: alpha principle or alpha rule or n plus L rule, right? Then we discussed about Hund's rule, and in the last we have discussed about Pauli's exclusion principle. What does alpha principle rule or alpha principle or n plus L rule tell us about? They basically tell us about filling of an electron from the lower energy level. Whatever will be the lower energy with the orbital, they will be filled first, or the shell or the subshell or the orbital, whatever they'll be the lower energy with, they'll be filled first. All right. Then we discussed about Hund's rule. What does Hund says? He says that in the p, or you can say in the d, in d there are 5 orbitals, in f there are 7 orbitals. So in these type of orbitals where the orbital are present more than one, you need to give them one electron, one electron, one electron first with the same spinning. Then if electron is remaining, then you need to start filling the orbitals, full orbitals. All right, then you need to give it an anti-spinning electron to that. All right, this is what Hund's rule or Hund's tell us about. Hund's rule is also known as 1-1-1 rule, since we initially allocate 1-1-1 electron to every orbital, right? Then we discussed about Pauli's exclusion principle, and that we have discussed in very detail. We have initially discussed that no two electrons will gonna have same set of 4 quantum numbers. They can have 3 set of same quantum numbers, however their fourth quantum number, the spinning of the electron, would always be different. So two electrons can possess the same set of 3 quantum numbers, however they cannot possess same set of 4 quantum numbers, right? So these are some rules of electronic configuration. Today we are going to solve the MCQs from the Sindh book first. Then we will be solving from the OETP, the NUST past papers guidebook. We will be solving it from federal book as well, and we'll try to solve from the Punjab book as well. All right, so this is basically from Sindh book, Sindh board book, right? So now let's see what does first MCQs ask us about. All right, okay, so wait for a minute. Okay, so Bohr theory is not applicable to which of the following species? Hydrogen, hydrogen plus, helium plus, and lithium plus plus. Alright, we have already discussed that Bohr atomic model is only applicable on the monoelectron species. Bohr atomic model is only applicable for single electron species. For single electron species, which means we need to check now from which of these will gonna possess only a electron. All right, we already know that hydrogen has a electron. All right, so hydrogen is correct answer, right? But helium, they are asking about Bohr theory is not applicable to which? Not applicable, which means an element which does not possess a electron, right? Then this means it would not be available, yeah, applicable on that, right? So hydrogen has already one electron, which means it will be applicable to this, right? Now as you can see the second question, hydrogen plus, hydrogen has already one electron plus showing that it has loosed one electron. If hydrogen has only one electron and that electron here has loosed as well, which means now H plus has not any electron, so which means hydrogen plus has zero electron, which means Bohr atomic model is not applicable to H plus. It is only applicable to the mono electron species. Now see helium plus 1. Helium has 2 electrons, 1 electron has been loosed by it and 1 electron is remaining, which means Bohr atomic model is applicable to helium plus. Then lithium plus 2, lithium has 3 electrons, 1 electron has been 2 electrons has been loosed by it, which means 1 electron is remaining. So lithium, it would be applicable to the lithium element as well, but it would not be applicable to H plus, right? So our correct answer is of course H plus, the B one. Nitrogen has the electronic configuration 1s2, 2s2, 2px. Now these are orbitals, orbitals, right? So 2px1, 2py1 and 2pz1. This 1 is basically showing us what? They are showing us nothing but they are showing us electrons. Alright, and this we have already discussed here, that if you have P, this is basically they are telling us about P, right? P subshell, and in P we have 3 orbitals. Alright, so initially we need to give them 1 electron, 1 electron, 1 electron. So this is what they are asking. So this is Hund's rule, right? Hund rule tell us about filling of an orbital with 1 1 1 first. So of course this is Hund's rule, right? So second correct option is C. Now the quantum number values 3s orbital are. Now we know that this 3 is for n, which means the shell number, and this s is for subshell, right? So n is equal to 3 and subshell we have discussed in the azimuthal quantum number, and azimuthal quantum number is represented by L. So n is equal to 3, L is equal to 0, because we know that when s subshell comes we have azimuthal quantum number 0. Alright, so there would be n is equal to 3 and L is equal to 0, which means the correct option is D. N is equal to 3 and L is equal to 0. Alright, now we have the radius of first orbit of hydrogen atom. We have driven this equation very well. This is fourth question. Radius, we have driven the entire equation for it as well, right? When we were discussing about Neil Bohr's atomic model, right? We got n square h square epsilon naught upon pi m z e square, right? Now let's separate this, the one which are constant, separate them apart, and if they aren't, put them apart. Alright, so we know that n square would be changed, h square is the constant, epsilon naught is the constant, pi is the constant, mass of the electron would be of course constant, and e square, which means charge of the electron would be constant as well. On up we have n square and on down we have z left, right? So this entire constant would be equal to 0.529 into n square by z. Z of course we know that is 1, alright, because we are talking about hydrogen atom here, right? And we are finding the radius of first shell. So instead of n we need to write 1 square upon 1, it would be of course 1. So the answer is 0.529 Armstrong. So let's see where this answer is. So here it is, right? 0.529 Armstrong. Now line spectrum is used as a tool for identification of course elements. There is the theory. I'm not gonna explain this since this is the theory, right? We are discussing here the the very difficult MCQs. Again, this is theory. In 1935 AD, James Chadwick was awarded Nobel Prize because Initially he discovered proton. No, of course he hasn't discovered proton. Proton was discovered by Goldstein, right? So let's write this here. Wait. So of course I don't know about the MCQ number. Okay, this is 6. So 6, we know that proton proton is discovered by Goldstein. We know that electron is discovered by William Crookes, or in some books there is written J.J. Thomson, right? So we are rewriting here J.J. Thomson. J.J. Thomson. And neutron was discovered by James Chadwick in 1932. James Chadwick, right? So let's deep dive into another options. Let's read the C first. He determined the radius of hydrogen atom. No, the radius of hydrogen atom was determined by Neil Bohr. So this is wrong as well. First one is wrong as well. C is wrong as well. He gave the rules for electronic configuration. Of course not. He has not played any role in the electronic configuration. So D is wrong as well. B, he discovered neutrons. So yes, this is the correct option, right? He has been awarded the Nobel Prize for discovering the neutron, right? In 7, when 4d orbital is filled, the next electron enter would be. Of course, we can find this by n plus l rule, or you can find it by the Affa principle, the one which we make, right? The table. So let's see if I do make here that 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 5s, 5p, 5d. Sorry, I forgot to write 4f. 5f. Let's make it till 6, right? 6s, 6p, 6d, 6f. Alright, so now let's make the arrows. Initially for 1s, then 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s. What they have asked us, electron will be going after 4d, right? So it has not gone in the 4d yet. Now it is going in the 4d, and after 4d it has gone to 5p. Alright, which means the 5p is the answer. B is the answer, right? So 5p is the answer. Yeah. Now let's read the 8th one. Which of the following is not an isoelectronic species? Iso means same electronic species, right? Sodium has lost 1 electron, which means now it has 10 electron, and neon has 10 electron as well, which means they are an iso electronic pair. Let's see this. Sodium is again 1 lost, so it has 10. Fluorine has gained 1 electron, so it has 10 as well. So 10 10, again isoelectronic species. Sodium has 11 electrons. Calcium, calcium has, I guess, 19 electrons, right? I'm not sure about it, but yeah, they are not isoelectronic species. So yes, this answer is correct, right? They have asked us not an isoelectronic species, so they are not isoelectronic species, right? Balmer series appears in the hydrogen spectrum where electron jumps from any appropriate higher energy orbit to the second orbit, because we know that when electron from anywhere comes to the first orbit, that is Lyman series. When electron from anywhere comes to the second orbit, that is Balmer series. When electron from anywhere comes to the third orbit, that is Peston series. When electron from come from anywhere and comes to the fourth orbit, that is bracket series. And when electron coming from anywhere come to the fifth orbit, that is bracket fund series. And when it goes to the sixth orbit, that is Humphrey series. But here they are landing to the second orbit, and that is Balmer series. Last but not the least, the shape of the orbital for which L is equal to 0. If L is equal to 0, we know that L is S means, right? If S is there, which means L is equal to 0, and S has the spherical shape, right? S has the spherical shape. So today we have done MCQs from the Sindh book. In the next video we will gonna do from the Federal, Punjab. We're gonna look into the KPK book as well. Then we will be going with OETP, the NUST past paper guidebook. This was all for today.